Hey, what's up, guys? This is Sean. So today, let's take a look at another Codeforce problem. This one, Christmas trees. So there are like n Christmas trees on an infinite number line, and each tree has its own position, right? And all the positions are guaranteed to be distinct. And so here, each position can either be occupied by a Christmas tree or by a human, or not occupied at all. And then there are like n peoples who wants to celebrate Christmas, and each of them has their own position, okay? And note that all values of these things should be distinct, right? And you want to find such an arrangement of people that the basically the distance, right, between each people to to the closest to any to its closest a tree is minimum, right? So basically, if there are like multiple trees, right, you want to place all those like m persons, right, in some positions that the total distance between the person to the closest tree of that person is minimum, right? And then it asks you to print out the total distance and the one of the arrangement that can meet that total distance. And here are some like the constraints, right? So 10 to the power of 5 and the coordinates, right? The coordinates is like within the negative to positive integer. Okay. So what does this one mean, right? So this thing is like there's like a line here, right? And it says there are on the line there are like some trees here, right? So they're like the tree here. Is this a tree? Probably not. Okay, I didn't plan to draw that thing. I think tree is something like this, right? Yeah. Yeah, this is a tree. Yeah, sorry about my horrible drawing here. So, okay, anyway, so let's assuming we have these two trees, right? And then we have like how many persons? We have m persons, right? M person people. And we want to place those m peoples in a way that, the total distance, right, between the persons and to any of the trees is minimum. So let's try to place them one by one, right? Let's say we have like how many of them? Let's say this is like 1, right? And this is like 10. So so what's the closest place, right? To place, of course, it's the place that's next to the tree, right? So basically, we're using like a greedy approach here. So for the first persons, there are like 4 places we can place that. Actually, there we can place either into here 0, 2, or 9, 11. It doesn't really matter, right? So I mean, anyone will work because any of those 4 positions, like 0, 2, 9, and 11, the minimum the distance they're all 1. So which means that if we place the first persons here, right, and here, and for the second persons, right, of course, then we have to put the second person on the remaining 3 positions. So here, and then the third person, of course, is here, right? And then the fourth person is right here, right? So for the first 4 persons, right, they're like we can place them on within this sequence, and then for the fifth person, assuming we have fifth person, then what's going to be the next? Next is going to be they're like here, right? -1, and then 3, and then 8, and then 12. So starting from the fifth persons, we want to place them like having the distance with any of the tree that's starting from 2. okay, and so on and so forth. So now, so this problem is like very similar to like the what to find the 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 shortest distance, right? The shortest distance from all the trees. So here, that's what's gonna be our solution here. So basically, we're gonna create a queue here, right? So we're gonna have like a queue here, and then at the beginning, we're gonna insert all the trees into this queue. We have T1, T2, and then to Tn. And then we're gonna use this queue to do a BFS search, right? And every time when we have so because the BFS search, every time we pop up like an element, it's always gonna guarantee that we're using the shortest distance, and the current distance will be the distance for the person. So and we'll stop once we have find m persons, and then that's when we need to stop. Yep, I think that's pretty much the logic here. So starting from the queue here, with the to by initializing the queue with all the trees, and then starting from the trees here, we're trying to find the do a DFS search one by one until we have searched the all m persons, and that's when we need to stop. Cool. So right, so to start the coding here, and we need to define a few things, right? We have int like n and m, right? So n is the number of trees and m is the number of persons, and we also need like the coordinates, right? The max n, right? That's going to be the coordinates of all the trees. So first, let's read the n and m, and then since we're going to do a BFS search, right? We need to read those elements into the queue. So I'm gonna have like dq with int, right? So here's gonna be the queue, and then of course, so for the DFI search, we also want to do like an int, right? So like a set for scene. So this is like exactly what is the problem it's trying to tell us, which means that you cannot if there's a person or a tree on the positions, you cannot place a person there. That's why we need like a seen or visited set to help us to record what are the place we cannot place the person, right? And then we just need to read the the trees in, right? So hi plus plus. Then the position is okay. So let's do a int p, right? That's the position. And then we do a q dot push back, right? So we push the q back with the positions, and of course we are also going to add this position into the scene set because of obviously the tree has already been occupied, right? So and so the next one is I'm going to get like the distance, that's the current distance with the tree, right? And then the second one is the what? It's the total distance, right? The total distance that will be using as an output. And also we need another one like vector of the answer because not only besides the total distance, it also asks us to print out one working arrangement. That's why we need the vector of answers to store the positions uh, of those trees of those I'm sorry of those persons. Okay. Mm, cool. And now we can start the BFS, right? So while true. So here's a little tricky part, because, since we have the trees here and we want to stop when when we have we have seen m persons. That's why we will be stopping inside the while loop, you know. not outside. So I'm going to have like int size of the current BFS search, right? Q dot size, and then I'm going to introduce like a flag to help me to quit to break the current while loop. So I'm going to have like a flag called exit. At the beginning, it will be false, right? And then in the end, after the current BFS, if the exit is true, right? And then it means that okay, we have seen m persons. That's when we will stop here, which means that we will just break. Otherwise, we just increase the current distance. So now the actual for loop here, right? So for I in int I is from 0, I smaller than size I plus plus. Okay, so here it's just like regular BFS template. Oh, so the current, right? Current will be the q dot pop of front, right? So and then we do a q dot pop front. Okay. So here I need to do a simple check because if the d is greater than 0, so the reason being is that since we'll be popping out the Christmas tree first, so it means that if it's Christmas, if it's d when d is greater than 0, it means that we are seeing like a person. If d is 0, it equals to 0, it means that we're popping the Christmas tree, right? So if the d is greater than 0, then I can accumulate the current d, right, to the total distance. And then the answer, right? So we push the current distance, the current position into the answer because that's going to be our like the one of the persons, and then we decrease the m. So and if the m is equal to 0, it means that we have processed all the persons. Then we just set the exit equals to true, right? And then we break from the kernel for loop. That's why I need another flag here since we have a nested loop here. And once the break will only break the for loop here. That's why I need another one to break the entire loop. Yeah. So that's that. That's to maintain the answers, and the rest is just like basically if the scene we're trying to find the current plus one and the current minus one. Basically with the current element, right? We're trying to see if we can place if we're trying to see if the next one, the left one and the right one is not occupied. If they're not, then we know we can push those elements into the next BFS, right? For loop. Scene dot find. Okay. End. Sorry. So if the current plus one has not been seen before, then we can just push that, right? Push back this current plus one. And then of course don't forget to insert this thing into the scene set. So similar with the current minus one, right? I'm going to copy and paste here. So minus one, and then minus one, and then minus one. So here just output, right? Now output first is the total distance, right? And then for the auto y, right? The answer y. Okay. Yep. So I think that's it. So let's try to run a few test cases. So the first one is this one. So we're expecting like 8. So the answer could be different because the sequence, since there could be multiple answers, as long as the output is the same, then we should be okay. Did I? Oh, I think the output is wrong. Okay. Yeah. Okay, so it's 8. So this one looks fine. And let's try another one. This one. So the answer should be 7, right? Yeah, so it's 7. Yeah, I think this should be working, right? And the yeah, so for the I mean for the time complexity, I think it's pretty straightforward, right? It's like we are like and we're stopping. We're stopping from the time complexity is that we're going to loop through all the trees first. So it's going to be n plus m, right? So after looping through all the trees, then we'll be looping through we're gonna looping through m persons, and that's it. Mm, cool. Yeah, I think that's it for this problem. You know, just like the you just have to uh, try to place try to place some persons and then it shouldn't be hard to find to realize that this is like kind of like the BFS, the shortest distance problem. And after that, it's just like a matter of how do you want to implement that. Cool. I think I'll just stop here. And thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.